When you're learning synthesis in organic chemistry, one of the synthetic steps is oxidation. That can be done a number of ways. So today we're going to talk about oxidation with chromic acid. So chromic acid is this right here. And it's a chromium double bonded to an oxygen choice and then with two OHs. And it's very corrosive, very nasty, very acidic. Don't get it on your skin, but it oxidizes things great. And it oxidizes alcohols and aldehydes. And we're going to go over how to use it and some rules it follows so you can use it in your synthesis. So we have our chromic acid here. Like I said, it oxidizes two things, but we're going to have three examples. All right, so we're going to start with the alcohols here. So for primary alcohol, which is an alcohol bonded to a carbon, bonded to one other carbon, it oxidizes it to a carboxylic acid. And this is actually what it does is first it oxidizes your primary alcohol to an aldehyde, and then that aldehyde to a carboxylic acid. It's what's called over-oxidizes it. It is a very strong oxidant. It'll take that alcohol as far as it can go, and if it's primary, it's taken to a carboxylic acid. For a secondary alcohol, which is an alcohol which is bound to a carbon, which is bound to two other carbons, it oxidizes it to a ketone. Because of where it is on the alkyl chain there, it's secondary, you can't over-oxidize it to a carboxylic acid or an ester. So it stops out of that ketone. So it's great that in that case, you don't have to worry about over-oxidation. It just takes it to your ketone. Then if you have an aldehyde, if you remember from the first step what we talked about, that will be directly oxidized to a carboxylic acid. Okay? So if you're looking to make a carboxylic acid out of an aldehyde, that's a great way. So chromic acid is, like I said, a very strong oxidant. It's super corrosive, super carcinogenic, so it's not really used anymore except for maybe in like research laboratories. However, it is still taught because it is an important reaction and it teaches a concept of reactive selectivity. So like with the primary alcohol, you have to know that it's going to over-oxidize that to your carboxylic acid. You can't stop it out at an aldehyde. So you would need to use something else. But say you're just trying to make a ketone from your secondary alcohol, then that's fine. So you have to remember when you're doing these synthetic problems on your exams that you might have multiple sites of functionality. So say you have an alcohol and a ketone on there, and you're saying, oh, I'm sorry, say you have multiple alcohols, and you're like, oh, I want to oxidize that to a ketone. It's also going to react with your primary alcohol, and it's going to push it all the way to a carboxylic acid. You might not want that. So you need to learn that synthetic selectivity in terms of reagents, especially oxidizing reagents, and which ones to use for which scenarios, so you can really become, I guess, synthetically nimble, for a lack of a better term. But hope this video was helpful for you guys. Share this with someone that's taken organic chemistry with you, or someone that you know is struggling. Share with, classmate, or a friend in another university. Just share it with anyone. Also, if there's anything you're struggling with, drop it below in the comments, or you can DM me. I do answer DMs. And if there's something you got wrong in your last exam or a quiz and you're just not sure why, send that over to me and I'll make a video walking you through it.